Hello friends, again welcome for today's video, and in this one we will continue our stack journey. So I hope you have seen the first part of our stack series in which we covered the introduction and the features. Then the only feature that stack has is its LIFO, last in first out. We saw all the operations that we can perform on a stack, push, pop, peek, top. We saw an example as well, and then we saw what different applications can be there for a stack. Today we are going to see the most important application and its live examples about the polish notations or infix, prefix or postfix notations. Very important one, and from your exam point of view also, definitely there would be a question on this one. Okay. So let's start for today's video. We can write an expression in three forms. We can write in infix, we can write as postfix, or we can write as prefix. What do you mean by infix? Infix means the operator. That means plus, minus, divide, multiply, all these things. They will come in between. That's why infix. They will come in between the operands. So 3 plus 5. This is in infix notation. Postfix notation means 3, 5 plus, and the prefix will be plus 3, 5. This is also called polish notation, and this is called reverse polish notation. And in the computer science world, most of the expressions are evaluated internally as postfix. So as a human, we generally prefer infix. That's how we are accustomed to. That's how we have learned the board mass rule throughout our school days. But when we come to computer science, they prefer the postfix one. And why? We are going to see later in this lecture. I'm going to cover that. But before that, what I'm going to do is I'm going to show you how to solving an infix expression using stack. So let's take any infix expression. So let's say our expression is, and we are going to take a very simple one, not a complex one, 3 plus 5 multiply by 2. Right? So we need to have parentheses. So for make it complete, and there are no parentheses in postfix or prefix. So you might have got a hint why those are preferred. Okay. So basically, when you are solving an infix expression, you have to take two stacks. Okay, so I will write the algorithm here. Take two stacks, one for operands and one for operators. So if you get an operator, push it into operator stack. If you got an operand, put it into operand stack. But so if you get operand, push into its corresponding stack. Now third point says if you get operator, so you have to make sure that just compare your current operator with the one at the top of the operator stack. Compare current one with top of operator stack, and whoever is the higher precedence, execute that first. So when you do have to execute, then first do comparison, then pop two operands and perform operation and then push result into operand stack, and then you can push the operator which you have not used, lower precedent, into its stack. If you get an opening parenthesis, push into operator stack, and when you get a closing one, so then you have to pop until you get the beginning one. So when you pop, you will get the operators, and for each operator, pop the two operands, perform the operations, and when you get the opening one, discard it. Okay, and do this until you are done with the entire expression. So I will keep these notes here so that you can see side by side, and we are going to perform the operation on this one. So as mentioned, we will be having two stacks. This is our operator and this is our operand stack. So, and our expression is, I will write here so that we can see easily, 3 plus 5 into 2. We get an opening bracket. So what we will do, see point number 4, push into the operator stack. Next we get 3. So this one is done. Next we get 3. What step we have to perform? Second one. See what is written at the second point. Push into the operand. Then you get a plus. Again, we get an operator. We will compare what is at the top. It is the parenthesis. Leave it. We will push plus here. Next we get 5. We will push 5 in the operand. Next we get a, so okay, plus and 5 we done. Next we get the closing parenthesis. What we have to do, point number 5, pop until we get opening parenthesis. So when we pop, so this plus will be popped out. Let me use a different pen. This will be popped out. Okay, so this will be popped out. So I can say that plus is here. So whenever an operator is popped out, we have to pop two operands, 5 in the reverse order. We have to write 5 and 3. So these two will be popped out. And when we are popping, what is the result? 8. It will be pushed back into the stack. So let's clean our stack. Right, and our result 8 will be into the stack, and then finally we have to ignore the starting parenthesis also, because till that we have to pop. So our next is multiply. This one we will push here, and our next is 2. We will push here. Now we have done our expression. So now we will keep on popping the operator stack. So we will pop this operator. This expression is no longer needed. We can remove this one. So star is popped. So when an operator is popped, we need two operands to perform it. So 2 and 8 will be popped. We can clean our stack. Result will be 16. It will be popped into the stack. So now the operator stack is empty. We can say that there is nothing in this stack. So our answer will be whatever is the top of the operand stack. Answer is 16. So that's how we need two stacks if we want to evaluate the infix expression. Now quickly check how we can evaluate postfix expression. Okay. Now this was solving infix expression using stack. Next we are going to solve is solving postfix expression using stack. Let's take a bit complex example. Okay, so as I mentioned, there are no parentheses in postfix. So it would be 5, 3 plus what we can take, say, okay, 8, 2 minus multiply. So with your eyes, it's not very intuitive how we can solve this. But if you see in terms of, if you think from the computer perspective, it is very easy to solve it using a stack. I mean, much easier than the above example that we saw for infix expression solving. Okay, so in this one, we will only be using one stack. There will be only one stack. That's all. And in this one, let's write the algorithm first. It is very simple. If you get an operand, push into stack. If you get an operator, then pop two operands from stack, evaluate using the operator, and then finally push into stack. That's it. At the end, you get the final answer in the stack, the only element left. And let's take the example how we can solve this. Okay, our expression I'm writing here also, 5, 3 plus 8, 2 minus multiply. We get 5.1. Let's use a different pen. We get a 5. It is an operand. Push into the stack. Again, this is done. Again 3. First point. Push into the stack. What is the next? An operator. Point 2. What we have to do? Pop two operands. 3 and 5. Perform the operation. So we will pop 3 and 5 out. So let's remove those. 5, 3 plus we have to evaluate. As you can see, pop two operands we have done. Evaluate. Answer is 8. Push into the stack. Now 8 is into the stack. Okay, great. What is the next? 8. Very good. Push into the stack. Next 2. Push into the stack. What we have got now? A minus. Great. So I can say we have evaluated this. So this can be removed. Now we have got a minus. So what we will do? Minus. So we have got a minus. What we will do? We have to, point number 2. Pop two operands. Which one will be popped? 2 and 8. 2 and 8 will be popped. Notice in which order I am writing. I am popping 2 first. I am writing it at the right hand side. So note that. Answer will be 6. Evaluate, push into the stack. This expression is done. So we can remove this. And now next is multiply. multiplies there. So we have to, point number 2, pop 2 elements, 6, 8. These two will be popped. So I will remove from the stack. 8 into 6, 48. Awesome. Expression ended. This is not needed. And we can say expression ended. What we see at the top, 48 as our answer. See how simple was it, isn't it? And when we were doing this, it was too much complex. See the algorithm steps from here to here. When you have to solve an infix expression. But when you were solving a postfix expression, only 2 steps. Third step I have just written, it is the final answer. So eventually you are just only doing 2 steps. That's all. So before end this video, why postfix or reverse polish notation, RPN, reverse polish notation is more used in computer science? First point, easier to evaluate, right? No ambiguity in operands precedence, right? That means no need of parentheses, because those are needed to remove the ambiguity for the BORD-MAS rule. Easy to evaluate, no need of parentheses, and that is why we can say efficient computation. Because we are only using single stack. Okay, so that's all for this video. In next one, what we're going to cover is, we will see how we can convert between these 3: infix, postfix, and prefix. How you can convert an expression between these. That we will see in the next video. So thanks for watching. See you again. Bye bye.